This is the online pendulum simulation that students will use to complete the pendulum data collection and processing activity found on the student Google site. The purpose of this data collection and processing activity is in two parts. The first part is for students to understand the relationship between the length of a pendulum and the period of its swing. And the second part is to manipulate this relationship between length and period using the pendulum period equation to calculate the value of gravity on Earth. Students may not be familiar with the second step of this data collection and processing activity, and if students and teachers look on the student Google site and the teacher Google site, you'll see that there is a pendulum data collection and processing instruction sheet that assists students in this second process. However, this may be a little tricky for students to actually understand, and teachers may find that they have to give students a little bit of help in understanding where they are supposed to go with this relationship. However, they can still process the data and still produce a good data collection and processing grade with a little assistance from the teacher. The simulation itself is pretty straightforward. You'll see that the green box to the right hand side of the screen is where you control the pendulum, all the constants and factors of the pendulum. For this activity, students are only going to manipulate the length of a pendulum, the length being the independent variable. You can see that if I decrease the length of the pendulum, that the pendulum starts to decrease to a length of 0.5 meters. The instruction sheet asks students to collect periods of pendulums for lengths at every 0.2 of a meter, so 2.5, 2.3, 2.1, etc. Therefore, you'd expect students to give you a possible error for length of the pendulum up 0.1 of a meter. However, it is possible with the other tools to use this measuring tape or this tape measure, and with the tape measure you can measure the distance between two points. The problem with the tape measure is that it's a little tricky to manipulate and a little fiddly to move up and down. I don't particularly like it that much, but you may find that students opt to do this, and if they opt to do this, then they may give you an error of to around about 1,000th of a meter. However, within the simulation, I've explained that using this value up here is good enough, so this, using the tape measure, becomes a little too inaccurate for me. So I've asked students in the video presentation for the on the student Google site not to use the other tools and just to use this 2.50 meters. Students measure time using the photogate timer, or the period using the photogate timer. Students are asked to release the pendulum always at an angle of 30 degrees. And students are also instructed that nothing else on this green box needs to be changed. Because friction is set to none, you'll see that the pendulum itself will constantly swing backwards and forwards to 30 degrees on either side until we press the red reset button down below. Therefore, to measure the period of the pendulum, all we need to do is press the start button, and once the pendulum passes the equilibrium position and then repasses it from the same direction, you can see that a time measurement for the period is given. Pretty straightforward. Students can then go and collect all the data they need and then to start to manipulate the data. And that's as far as this simulation goes for this data collection and processing activity. However, you can see that in this green box at the side there are other things that we could start to look at. For example, we could start to change the mass of the bob, and we could look at how mass relates to the period of a pendulum. We could also change the release angle from which the pendulum is released from, and see if we get same time periods at higher or lower release angles. Therefore, this simulation has lots of reusability. Another thing that I like from this green box is we can start to add velocity and acceleration measurements. Or we can start to look at velocity and acceleration relationships. And when you start to look at simple harmonic motion from the IB syllabus, this would become a very, very useful simulation to see the relationship between velocity and acceleration. And as well as this, we can also look at energy, and we can start to see what's happening with the energy in a pendulum. If I reset this and make it go from a lower angle, you can see this more clearly. Now this is where the real time, quarter time, and 1/16 time comes in useful, because we can start to slow it down. And although we can't take values or measurements from these graphs at the moment, you can see that we can pause the whole scenario, and you can start to look at relationships and look at the size of arrows and start to look at what's happening between the potential energy and kinetic energy and the velocity and acceleration. You can also increase the friction on the pendulum and start to look at how friction affects pendulums, being another reusable factor. The last thing that is quite useful within this simulation is that because it's a simulation, we can start to change the value of gravity. So in the second process of the assigned data collection and processing activity, we look at the relationship between length and the period of a pendulum to try and calculate, and then use this relationship to calculate the value of gravity on Earth. You could change this to the value of gravity on Jupiter and produce this and do the same data collection and processing activity, but for another planet. Therefore, this simulation has got lots of reusable functions, and the data collection and processing activity that I've assigned for this particular simulation is only one possible scenario that you could use to collect data. Thank you very much.